In this video, I'm going to be looking at variables as an aspect of designing psychological research. And we'll begin with independent variables. In simple terms, an independent variable, IV for short, is a factor or condition that you change or control in an experiment to see how it affects other things. It's like the cause in a cause and effect relationship. An example of an independent variable could be the amount of sleep participants get before taking a memory test. Researchers might manipulate this variable by having one group of participants sleep for 8 hours and another group sleep for only 4 hours. And they would then compare the memory test scores of the two groups to see if the amount of sleep, that's the independent variable, has an effect on memory performance. In this case, the two amounts of sleep, that is 8 hours and 4 hours, are the two conditions of the independent variable. Following on, we have dependent variables. A dependent variable, known as the DV for short, is the outcome or effect that researchers are interested in measuring or observing in an experiment. And it's called dependent because it depends on or is influenced by changes in the independent variable. In the example of the research on sleep and memory that I mentioned a moment ago, the dependent variable would be the memory test scores of the participants. The researchers are interested in seeing how these scores are affected by the amount of sleep the participants get, which is, as I've said, the independent variable. So, in brief, a dependent variable is influenced by an independent variable and it can be measured. Now to extraneous variables. An extraneous variable is a factor other than the independent variable that might affect the outcome of an experiment, thereby potentially influencing the results in a way that makes them less reliable. These variables need to be controlled or accounted for to ensure that the experiment accurately measures the relationship between the independent and the dependent variables and nothing else. And in the context of the sleep experiment I've been referring to, where the independent variable is the amount of sleep and the dependent variable is memory test scores, an extraneous variable could be the participants' caffeine intake, for instance. If some participants consume a lot of caffeine before the memory test, this could affect their performance on the test, regardless of how much sleep they got. So to control for this extraneous variable, researchers might ask all participants to avoid caffeine for a period of time before the test, thus ensuring that any differences in memory test scores are more likely to be due to the amount of sleep rather than caffeine consumption. Right, let's have a look at situational variables. A situational variable is a type of extraneous variable that refers to aspects of the environment or situation in which an experiment is conducted that could affect the participants' behavior and consequently the results of the study. For example, in our study on the effects of sleep duration on test performance, the temperature of the room, the noise level, or the time of day could all be considered situational variables. If the room is too hot or too cold, if there's a lot of noise, or if the experiment is conducted late in the day when participants might be tired, these factors could influence their performance on a task, potentially confounding the results. Oh, and an extraneous variable that has the effect of confounding the results of a study is also known as a confounding variable. To control for situational variables, researchers try to keep the experimental environment as consistent as possible for all participants, or be able to account for these variables in their analysis. Now let's look at participant variables. These are also a type of extraneous variable. Participant variables are characteristics of the individuals participating in a study that can affect the outcome of the experiment. Participant variables are intrinsic to the participants themselves and include factors such as age, gender, intelligence, personality traits, cultural background, and prior experience, to name just a few. Unlike situational variables, which relate to the external environment, participant variables are internal to the individuals. For example, in our study on the effects of sleep duration on memory scores, we would need to ensure that things like the participants' ages, genders, state of health, etc. are all factored in. Otherwise, we might find that the dependent variable is being influenced by one or more participant variables as opposed to the amount of sleep that the participants are getting. So, if I was conducting that experiment, I'd try to make sure that all the participants were similar as far as age, gender, health, academic ability, and any other factors that might result in something other than the differences in the amount of sleep being measured. Now, you can't always take out every kind of extraneous variable, but you can limit their effect by ensuring that you standardize the procedure that you're doing. In other words, you make sure that the situation and the procedure of your experiment are exactly the same in all conditions of the investigation. So let's say there's traffic noise outside when you are doing a memory test with participants. Well, in order for the procedure to be standardized, you need to make sure that that level of traffic noise is exactly the same for all the people you're testing. And yet another type of extraneous variable can be that of order or sequence effects. A technique used in experiments to minimize the effects of order or sequence effects on the results is known as counterbalancing. It involves systematically varying the order in which different conditions or tasks are presented to participants. The goal is to ensure that any potential order effects are evenly distributed across all conditions so that they don't bias the results. For example, in an experiment with two tasks, task A and task B, half of the participants might do task A first and then task B, while the other half do task B first and then task A. In this way, if there's any advantage or disadvantage to doing one task before the other, it's balanced out across all participants. And any differences observed in the results can be more confidently attributed to the variables being studied rather than the order in which the tasks were completed. A similar approach to counterbalancing is randomization, but this is where each participant experiences either the first or second condition of the independent variable as a matter of chance. And that's the order of the conditions. A similar approach to counterbalancing is randomization, but this is where each participant experiences either the first or second condition of the independent variable as a matter of chance. That is, the order of operations is randomly assigned. Another form of extraneous variable can be demand characteristics. And that's where the participants might answer or behave in a certain way because they think it's expected. Well, one way of controlling demand characteristics is what's called a single blind technique. And that's where the participants don't know about the aims or expectations of the study. Obviously, that means that certain information about the procedure is not told to them, and this is where ethics can become an issue. An example of a single blind study is where participants are told they're being given a certain type of medication, but they don't know that half their number are getting a placebo, in other words, an inactive substance. And lastly, in this video, let's have a look at double-blind techniques. A double-blind technique is where neither the participants nor the researchers involved in data collection or interacting with the participants know the aims of the study. And one way to do that is for the researcher to employ independent observers to gather data. I hope you found that worthwhile. It's very important that you do know about all those types of variables and how to control for the ones that you don't want to interfere with the results of your investigations. And you need to be able to apply that knowledge to hypothetical situations. That is, imaginary but practical scenarios that you might be given in an exam. Best wishes, everyone. Bye.